Hi, and welcome to this K-12 International Academy Flipped Instructional Session. This is Middle School Earth Science Semester A. Today's topic is Lesson 2.14, the rock cycle, and I am Mrs. Fessel. The rock cycle. It's hard to believe, but rocks are always changing. You may know that igneous and sedimentary rocks can turn into metamorphic rocks with heat and pressure. But did you know that metamorphic rocks can eventually become sedimentary or igneous rock? Rocks are formed, moved, and transformed in the rock cycle, which is our topic for today. As you watch this video, think about the different rocks you have seen while outside. Which part of the cycle might they be in? Here you can see water breaking off metamorphic rock. The metamorphic rock becomes sediment, which may become to the ocean. Then that sediment may turn into layers. Those layers cement together, forming sedimentary rock. The rock then may sink and melt and become molten. If the magma leaves the Earth's crust and cools, it becomes igneous rock. Explore the rock cycle. From sediment to rock. You may be wondering how rocks change from one kind to another. Take a trip through the rock cycle to find out. Start in a river where sediments, as you learned in previous lessons, are loose rock fragments, grains of rock or sand, minerals, or shells and remains of small living things. So those sediments can begin their journey in a river to become a rock. Rivers can move a lot of sediment when they are moving quickly. However, when a swiftly moving river meets a lake or ocean, it loses energy. It can no longer carry the sediment. The sediment stops moving forward and settles to the bottom. This sediment spreads out in a horizontal layer. That river will bring more and more sediment out to the ocean, and that sediment will settle and create more horizontal layers on top of the older layers. Think of the folder or binder or even books you keep for school. As you get more and more assignments, the pile builds up, and builds up. The oldest assignments are on the bottom, and the newest ones are on the top. Layers of sediment are deposited in the same way, with older layers on the bottom and younger layers on the top, such as this video will show. You can see that, as we talked about, the river washes sediment down into the ocean. Those layers of sediment build up after time. Each time it rains, each time the river runs through, you can see the layers of sediment forming. Mudstone. Over time, the river deposits tons of sediment into the sea. These deposits form a series of layers. The buildup of layers puts pressure on the layers at the bottom. Water gets squeezed out, and the sediments cement together and become rock. This is how sedimentary rock is formed. As we know from previous lessons, sedimentary rock is a type of rock that is formed when sediments are compressed and squeezed together. The three most common types of sedimentary rock formed in this environment are sandstone, siltstone, and mudstone. If the sediment deposited is very fine-grained, the rock is mudstone. Fine-grained sediments result in siltstone, and medium-grained sediments result in sandstone. All right, in our flipped follow-up, we'll review how sedimentary rocks form. Next, we have from sedimentary to metamorphic rock. Next, your journey takes you millions of years into the future. Through the years, the mudstone has been pushed deeper and deeper into the earth. It has changed very slowly. As pressure and temperature build, the mudstone changes physically and chemically. A metamorphic rock has formed. The mudstone has turned into slate. A metamorphic rock is a rock that has undergone change from heat and pressure, but does not melt. Usually mudstone is transformed into shale, another sedimentary rock, and then into slate, a metamorphic rock. So as we play the video here, you can see that up here is where our sedimentary rock is forming. Eventually, that sedimentary rock may get pushed deep, deep into the earth, where it undergoes great heat and pressure, and that's when it can change into a metamorphic rock. So that metamorphic rock can then possibly change into an igneous rock. So we can see the sediment turn into a sedimentary rock, the sedimentary rock can turn into a metamorphic rock, and now the metamorphic rock can turn into an igneous rock. The slate that just formed may continue to get pushed even deeper into the earth, where it's even hotter. The increasing temperatures may cause the rock to partially melt. This creates liquid rock or magma. The magma moves towards the surface, which causes the magma to release heat and energy and begin to harden. The magma then cools and solidifies. Sometimes the magma reaches the surface before cooling. When this happens, the magma becomes lava, because lava is simply magma that's outside of the earth. That lava can cool and solidify as well. In both cases, igneous rock forms. So an igneous rock is simply a rock that forms by the cooling and solidification of hot liquid, magma, or lava. Obsidian is an igneous rock. It is black because it forms from lava, which usually dries into a black-colored rock. We play our video here. We can see how magma builds up under the Earth's surface. As it comes up and out of the volcano, it cools into igneous rock. It can also cool deep within the Earth and form igneous rock there. Intrusive igneous rock forms in the Earth, whereas extrusive igneous rock forms outside of the Earth from lava. All right, so here's a great example of the rock cycle. Here's how rocks can go from one form to another, and it's not always a straight line. Magma can cool and form igneous rock. That igneous rock could then weather and erode and form sediment. If it gets compacted and cemented together, that sediment can form sedimentary rock. So as you can see, it's not always a perfect cycle. Sometimes a sedimentary rock might get turned right back into sediments instead of turning into a metamorphic or igneous rock. So these are the four most important things that can cause rocks to change. Cooling and crystallization, right here, turns magma into igneous rock. Weathering and erosion can cause any type of rock to be transformed into sediment and then deposited in layers. Cementation and compaction can cause the sediment to become sedimentary rock. And finally, any type of rock can turn into a metamorphic rock with enough heat and pressure. All right, we'll do some activities about how rocks change in our flipped follow-up. And how fast is this happening? The rock cycle takes a really long time. Have you ever seen sand instantly turn into sandstone? Of course not. For the most part, the rock cycle operates on a time scale of thousands to millions of years. The majority, or most, a greater number, of the rocks are transformed over a long time. However, some phases of the rock cycle can happen very quickly. If a meteorite hits the Earth, the heat and pressure can create metamorphic rock in an instant. If a heat wave comes through, rocks can be broken down into sediment very quickly. Although these situations are fairly rare, they're an important part of the rock cycle. So we're not going to do the next activity because we will do it in our flipped follow-up. Speaking of our flipped follow-up, I hope to see you for the flipped follow-up. Look for that flipped follow-up session in your Class Connect schedule. Attend the live lesson to carry this topic into further practice, which would be practice with the rock cycle. If you need help, be sure to attend the Help Lab sessions for extra support. As always, have fun learning. Have a great day.